Assalamualaikum and good morning all.
Waalaikumsalam.
So today we will continue with our meeting on the last Monday about the task given to us by the Omicron Data Cybernetic Company, which to analyze the quality of memory chip manufacturing process. I guess all of us have our own work to be shown and discussed regarding in this meeting. So I will start the meeting with showing the tally sheet of the sample size of 180 on the Monday and evening shift of Tuesday. The tally sheet, which also called a cheat sheet, is a very simple way to accumulate data about the frequency of occurrence of event. It is simple, flexible, and effective of data collection tool where we collect the data we collected in real time and the location it is generated. So first thing first, we need to calculate the range of the sample. Range is equal to the difference between the highest and the lowest value of the sample data. So the range of the morning shift is equal to 1.449, and also meanwhile the range of the evening shift is equal to 0.989. Next, for the number of cells which can be obtained from the formula of range can be divided by the interval of value and the 10 plus with 1. The interval value must be odd number. Hence, for the morning shift, the interval value is 0.09, and the evening shift is 0.07. So this is because the number of cells is usually an odd number, so that the peak of distribution can be seen from the histogram, which will be shown by Hazim later. So the number of cells of the morning shift is 17, meanwhile the evening shift is 15. So after that, the lower and the upper class boundary can be calculated by the following formula, which is the first midpoint minus the half of the interval value and the lower boundary plus the interval value. So the value of each boundary are shown in the slide. Hence, here are the tally sheet of both of the shift on Tuesday. So that's all from me. Hazim, do you want to go next?
So, good morning everyone, and thank you to Mr. Faridz for inviting me to give a little bit information on our analysis. So first, before this, we already know about the tally sheet, which is already explained by Mr. Faridz. And now I'm going to explain more on the histogram, which gives a further understanding based on the sample that we've taken. Okay, so histogram is actually a useful tool or a good tool for early analysis. It is useful when some baseline data was collected and understood when to focus on the improvement. Now, we want to further improve our understanding of the sample in the form of histogram. Okay, so a histogram is a good tool for early analysis. It is useful when some baseline data was collected and understand where to focus on the improvement. Okay, first of all, as you can see, this tally sheet table, we already get the class boundary. All of the information for the construction of histogram is already being done by Mr. Faridz. So right now, we just want to convert this tally system into a histogram, okay, into a number of cells, okay, to represent the frequencies for each class boundary. Okay, so what can we interpret here is that the variation or the distribution of the sample of the data is very wide, because we already know that the sample or the standard weight that we have targeted is 3.56 gram. But we can see here the distribution or the variation of the data is very wide. So we want to know what is the problem, and we want to improve the quality of the manufacturing process. We have to come up with an effective plan to improve the quality of the manufacturing process, so that we were able to meet the standard weight targeted by our company. So I guess that's all for me. Is there anything to add up?
I have something to add up.
Okay, good morning to everyone. I have something to add up to improve the quality for our sets of data for the memory chip. So I think we need to introduce or use the quality tool of Pareto chart. So Pareto chart, it shows
the most frequent frequency of the set of the data. So the bars are ordered from the highest to lowest frequency. So Pareto chart was invented by Wilfredo Pareto in 1897 to evaluate the most frequent in a categorical value. For our project, we have a set of data for the weight of memory chip, so we need to sort the data based on the most frequent frequency of the chip based on the weight of each individual aspect. Using a Pareto chart, we can observe the most frequent weight for the memory chip in our sample based on the Thursday first and second shift. So to construct the Pareto chart, we need to sort the weight of the frequency of the Pareto chart in descending order, and then we need to calculate the cumulative frequency for each of the weight, and then also we need to figure out what is the percentage for each cumulative frequency, and then we can construct the Pareto chart using two vertical axes and one horizontal axis. The first axis indicates the frequency of the weight, and the second is indicating the percentage of the frequency. And for the horizontal, it will indicate the weight for the memory chip in our Pareto chart. Okay, for the Thursday first shift, it has the highest frequency of 26 for the weight of memory chip of 3.63, while for the second shift, for the Thursday shift, it has a frequency of 35 with the highest weight of the memory chip with 3.352. I think that's all for me based on the quality tool to improve the quality of our data based on the weight of memory chip. So Faiz, do you have anything to add in our schedule?
Of course. So I will add up on our production process performance. So basically we can use the X bar and R control chart to analyze and evaluate our data. Either our production process performance is in control out or out control. So basically the X bar and R chart are a pair of chart that we use to identify and monitor the process variation over the time. Taking example from the data on the Thursday, we can see in our control chart that there is two outlier that can be observed, which is from the group 17 and group 15, where this shown that our production process is out of control. Meanwhile, from the Thursday evening, we can say that our production process are in control, as there is no outlier that been shown in the control chart. Therefore, our company advised that the company to do on-site inspection for the factory process, so we can eliminate the special cause variation that causing the process is out of control.
So this concludes our meeting for today's meeting. As our information gathered regarding the analysis on the memory chip will be sent to their manufacturing team to improve their memory chip for the company. So anyone have any question? Okay, since no other question, we can conclude our meeting and we can dismiss. Thank you all.